Hi, Professor. Good afternoon. I'm here with my team, Lahir Mahasaya Vesta and Mahesh Mergu, to give a presentation on road damage inspection with distress types, severity levels, driver alerts, and geotagging. In this project, we are going to discuss more about the road damage inspection with distress types. Distress types is nothing but the damages which are caused to the roads or pavements, and the severity levels. I mean, the level of severity we have with these roads, and also driver alerts are we provide advanced in alerts to the drivers in advance who are traveling to that road. And finally comes the geotagging. Geotagging is something like we mark that location uh, with that distress or with that damage done to the road at that point in the map, so that we can send that data to the concerning authorities, so that they can take necessary action, like coming with have an inspection of that place, uh, check the severity of the damage, and take a preventive measure uh, based on the severity. Yeah. Moving on to the introduction of this presentation. Yeah, coming to the introduction, road damages it is very hard to prevent road damages, because there can be many causes for road damages, such as environmental conditions, traffic load, and it is very crucial for us to monitor these damages, so that we can have a efficient transport system and a safe transport system to its users. Actually, road damages can be of various types. They come in various types and sizes, like cracks, potholes, ruts. These definitely pose a severity threat to the users, like accidents. And yeah, this might even lead to life damage, I mean, life threats. So necessary measures should be taken to avoid this. In addition to that, the unrepaired roads which are there can they can easily get worse and worse, which causes more further repairs, which is not desired. So yeah, generally we have a manual inspection. I mean, in traditional methods, we generally have a manual inspection where an inspector goes throughout the road. I mean, in examining throughout the road, and it takes manual effort. It's a lot of manual effort, and it is not even regular. Like, you can even miss a crack if it happens between the inspections, so that might have dangerous effects on the users. So yeah, coming to the right types of those road distress, we have longitudinal cracks, traverse cracks, potholes, and alligator cracks. Uh, Generally, these are the traverse cracks. Uh, Transverse cracks. These are the horizontal cracks which happen across the roads. And coming to the longitudinal cracks, these are along the parallel side of the road. Potholes are like a pit kind of thing you have in between the road. And alligator cracks, there are uneven types. They are like, you see this, right? These are the alligator cracks which might happen on the roads. Moving on to the next slide, we have the reasons for these cracks as well. The longitudinal cracks generally occur for poor joint construction, pavement shrinkages, and repeated and heavy traffic loads. These are the main reasons for this longitudinal cracks. Whereas the reasons for the transverse cracks are temperature variations, because over uh, over the period of time, the seasons changes. So due to this temperature variations, the pavements shrink, and there might be cracks developed. So due to this temperature variations, we have this transverse cracks. And coming to potholes, potholes are like uh, occur when the water seeps into the cracks. During rainy seasons, the water seeps into the roads, and it damages the roads. So even during winter season, the roads contract due to the ice and snow which falls on the roads, and these also leads into potholes. And uh, coming to the alligator cracks are mainly due to the heavy repeated traffic loads. So yeah, those are the types of distresses, and the next part would be continued by my teammate Lahiri.
Hi, Professor. Now I'm going to discuss about our project and the related work which we have done. So, automated road damage inspection. road damage identification is has been like a critical part for the roads, like road checking, and as well as the road damage detection, and as well as repairing the roads. So nowadays the deep learning techniques has been pretty much used in all the scenarios. So now we are trying to use that deep learning technology in the road damage detection as well. So there are already several papers which are written across the deep learning domain in solving the road damage detection. So one of the approaches is convolution neural networks, where they simply classify types of road detection, whether the road is damaged or not damaged. So, and that has been improvised using the YOLO models. That is, you look only once. Which what it does is it is a regression model which tries to identify the object in the image which is given, and it will pinpoint the location of the distress so that the road repair can be done easily, and as well as the avoidance of the defections can be managed easily. So here the YOLO models and also there are some of the segmentation models where the they will exactly segment the cracks where the cracks are present, and they will showcase the location of the cracks. And using these technologies, we can easily detect the types of distresses and differentiate the distresses, and as well as we can also do the severity levels as well. So by using all these technologies, I think like it is possible for us to create an automated road damage detection system, which will help us to reduce the road repair cost. Because if we detect the cracks earlier, so it will only go with the repairing of cracks. But if we delay the repairing of the cracks, that cracks might turn into alligator cracks, and the alligator cracks might turn into potholes. So the repair of the pothole will cost us more because we need to lay one patch of road on it. So the patching is takes much more expensive. When it comes to repair of linear crack, it's just spraying the tar on it. So can you go to the next slide, Sharon? So the severity evaluation prioritization. So as Sharon has explained about different types of cracks which we have, that is like a traverse crack, longitudinal crack, alligator crack, and potholes. So what happens is the initial stage, the first lowest severity crack is like linear crack, and the linear crack is developed into the traverse crack, and the traverse crack is once again connected to the longitudinal crack, and the longitudinal crack will goes to the alligator crack. So that is the cycle of distresses which it's going to happen. So now if we if we try to predict the like we'll be trying to build a model which will be classifying the distress and also telling the severity of the distress. So what happens is now if there are 2 to 3 traverse cracks in one image, so that might be taken as a low severity. If there are like 5 to 6 traverse cracks and as well as longitudinal cracks across the image, so we can go for that as an high intensity, because that might be developed into a pothole. So in this way, we will be trying to determine what is the intensity of the crack which has happened in the particular image, and we will be tagging that location so that like it can be used by the road repair team, so that they can exactly pinpoint the location where the crack has happened, and they can rectify the or repair the roads. So, and in this, like we'll be only using 2 categories, that is low intensity and high intensity. So as you can see in the image, so the low intensity has only 2 cracks, and the high intensity has alligator crack, and there are multiple cracks which are appearing on the road. So like, can you go to the next slide, Sharon? So yeah, geotagging and the driver alerts. This is a pretty important role which plays in our project, because geotagging of the road cracks is a pretty big deal, because exactly pinpointing the location of the crack is very critical, because that allows the road repair team to exactly go to the location and make the repairs fast. And as well as it will also we are also trying to integrate this solution to the map system such as Apple Maps or Google Maps, like by through an API services, where like it will directly inform the driver who is traveling the road that there is a damage in front of him, or else like it will directly open up the camera of his phone, where he can detect the model will try to detect from the phone camera, and it will alert the driver there is a pothole in front in 100 meters, and my driver might get a chance to slow down. So by this, what happens is the drivers will be doing a very pretty much safety drive, and as well as it will help the people to travel faster and safer. So yeah, and here we have used multiple papers. Like one of the papers is provided by CNN Logic, and other one is used by YOLO Logic. and other paper is used for the severity, and another one is used by using the wavelets, where we will be trying to determine the depth of the crack by using the ultrasonic sensors. So yeah, so this is the part where I will be handing over this presentation to Mahesh, who will be trying to discuss much more deeper about the related works which we have done. Thank you, Professor.
Yep. Thank you, Lahiri, for handing over the presentation to me. So I'll just share my screen quickly and I will just go take you through all the work that we have referred, the related works which we are referred for this whole project that we are doing right now. So, Professor, I hope you have understood each and everything my teammates have tried to explain you. So I will just take up you to the related works and observations which have come across while doing the research on this project. Because every solution, I hope, I think like every problem has been solved previously, but we are trying to do it in much better way and a much efficient way. For that, so in the earlier solutions that have been proposed by various other people in the past, so we have taken some few of the models which they have used it. Among those, the top five, top six that we think are pretty much useful for us are, I've mentioned over here. The first one is CNNs and deep learning. CNN stands for like convolution neural networks, and deep learning. Okay, numerous studies show how precise and accurate these technologies are, so that these can be resulting that they might be used to identify and classify road damage. YOLO models, like my friend already told you how the YOLO models are used and what are they used for. So YOLO basically stands for you only look once models. These are known for their exceptional recall and precision real-time detection. There's no competition for those models in the terms of their precision and recall time. Okay, so YOLO models are pretty much very helpful in early hazard identification, because as we all know, prevention is better than cure, right? So that's why we are using the YOLO models. And transform-based networks. These networks have demonstrated functional in complicated context due to their high mean average precision and accuracy. In the coming slides, I will show you how much is the accuracy that these models have shown us in the earlier researches. So that's the reason. Just bear with me for the next slide. I will just show you all the stats about it. Then we go to the SVMS and HOG. So the SVMS stands for support vector machines, and HOG stands for like histogram of oriented gradients. Of which these two systems offer you a decent accuracy, but whenever you are using for a large and complicated data set, this offer a decent accuracy. They typically perform worse than the deep learning methods, but when you are having a complicated data set, these are doing the job done. Okay, so let's go to geotagging, which is like very much crucial in a project, because when you see a crack, you have to look at that crack as well, right? You just can't take the pictures and keep it. So the geotagging is used for giving a precise location of that crack on the road, where it is and how far it is from the current station from you. That's all is done by geotagging. Then we come to real-time alerts, because just doing all of this is not enough. You need to get the alerts as well, so that you can be remembered or you can be notified that there is a crack on the road, and then you have to go there and do the fixing and everything on that. So in the next slide, we'll be going to the we'll be going to the table of comparison. Like this is a brief comparison between various methods that we have found in the earlier research works. And I will just take you what was that methods, and I will just give a short description about those methods. The matrix basically means the methods that were used in these technologies. Okay, and how much was their precision and accuracy. So first we'll go with the convolution neural networks, which is the CNNs. These are described as like a deep learning method for classifying and identifying road damage in images. So the metrics that were used were precision, recall, F1 score, and accuracy. And if you see the accuracy score for CNNs, it's 85.6%, and the precision came out to be 92.3%, which is superb and phenomenal. Then we go out to the deep learning term used to describe sophisticated neural networks that are used to identify and categorize and access road damage. For this, the matrix they used were is same accuracy in F1 score, and the score for that came out to be like 85.6%, and the accuracy was 90.5%. YOLO, I told you it was just one of phenomenal model. Okay, you only look once. That what it stands for. Road damage is recognized in photos by real-time object detection, and precision for that was 93%. I told you that the highest among all of this. And then the recall was around 88%. Then we go to transform based networks, a deep learning model that improves road damage identification accuracy by being tailored for sequence to sequence tasks, and the metrics for accuracy and mean aggressive progress. Okay. Um, we go to the support vector machines, a machine learning method for classification of applications such as pothole detection, and you can also identify the cracks. Like my friend already explained you, the different types of cracks, the alligator cracks and other different cracks. Okay, and the matrix was used for a precision recall and F1 scope, and that came out to be like 88%. Then histograms, which is HOG, uh, a feature, a descriptor for classifying and identifying objects like cracks in the road, and the metrics were the same: accuracy, precision, and recall. This score, it was already mentioned in the previous slide, was it used to be like it does a decent work, so the accuracy is somewhat about 84%. Then you have the continuous wavelet transform, a method for looking irregularities and patterns in the road surface, such as cracks. So the matrix was precision and recall. Then the its accuracy came out to be 80%. Geotagging, I told you, it is used for locating the crack or the pothole on the road. So for that purpose of mapping and resource allocation, discovered road damage in a given geo coordinate, location and precision, location precision and integration time. The precision was pretty high on this. It was 95%. Then we go for the real-time alerts. That is like you get all the notifications whenever there's a crack or something. So systems that instantly alert vehicles to the risk and damages to the road. So let's go for the next slide, which is a summary of all the approaches that we have done, and this is a summary like what we have gone through and everything. So in the summary, I would say the CNN's accurate distress detection and classifications, that its accuracy came out to be 85.6% to 92.3%, because that basically uses a deep learning method, and which is a quite very good one to do that. And YOLO, real-time detection of distress and classifying based on the distress type, YOLO gave out about 90%. And then classify the severity based on type of distress and intensity of the distress. The transform networks, on the other hand, it gave a very high performance in complex environments. The the accuracy for transform networks were 91%, which is super crazy for that. And geotagging and driver alerts, which is for like enhancing safety and efficiency. Based on these approaches, we're going to design and implement a pipeline which helps to give real-time defect detection, severity measure, and damage alerts and geotagging for the road repair. So in the next slide, we'll show you the references that we have taken for this whole um, thing. And lastly, I would say a thank you for listening to our presentation and bearing for us this time. I hope you have understood everything. And thank you so much, Professor.